I'm presenting on the mathematician Euler. Euler was born in April 1707 in Basel, Switzerland. His father had originally intended for him to be a pastor. Euler was a friend of the Bernoulli family. He became the chair of mathematics at the St. Petersburg University of Sciences, and he later moved to Berlin. His right eye went blind in 1783. Later, Euler became completely blind, but this did not stop him. He continued publishing scientific and mathematical papers until his death in 1783 in St. Petersburg, Russia. Euler did lots of important work in calculus. He wrote a textbook on differential calculus. He proved the power series expansions for e to the x and inverse tangent. Euler used the power of power series to solve a famous problem called the Basel problem. The constant E is named after Euler. Euler invented a method to improve the approximation of integrals that is named after him, Euler's method. We studied this in class earlier this year. The Basel problem. The Basel problem was proposed by Pietro Mangoli in 1644. It asked for the summation of the reciprocals of the squares of the integers. Euler used power series to prove that the sum was equal to pi squared over 6. He later published a somewhat more rigorous proof. Euler also did lots of important work in number theory. He proved Fermat's little theorem, which will be described in the following slide. He also did lots of important work in prime numbers. He studied Mersenne primes and used this research to prove that 2 to the 31 minus 1 is a prime number. For a long time, this was the largest known prime number. Euler also invented the Euler-Totient function. The Euler-Totient function counts positive integers up to a given integer and determines how many of them are relatively prime to that integer. Euler proved Fermat's little theorem, which states if p is a prime number, then a to the p minus p is a multiple of p for any integer a. Euler also did a lot of other important work. He solved a problem called the 7 bridges of Königsberg. Euler's solution to this problem marked the beginning of a mathematical discipline called graph theory. Because this is a presentation, I will use this picture to illustrate. The question is whether a traveler can walk along each of the bridges in this picture, symbolized by a green dot, only once. For example, a traveler might attempt to walk through this. A traveler might try walking across this bridge, to this bridge, to this bridge, to this bridge, to this bridge. But then he is presented with a choice. He can either cross this bridge, but then he won't have crossed this bridge over here. But if he crosses this bridge, he cannot cross this bridge over here. Ultimately, Euler proved that it is impossible to only walk along each of these bridges once if you were trying to avoid the water. This is my bibliography.